Hello, everyone, and welcome to today's Energy Storage News webinar on Commercial and Industrial, or CNI, Energy Storage Technologies with Honeywell. My name's Andy Colthorpe. I'm the editor at Energy Storage News and Deputy Editor-in-Chief for Publishing at Solar Media, part of the Informa Markets Group. In this session, we will explore commercial and industrial energy storage technologies for flexibility and resilience, and how these can facilitate adaptation to the power grid's new paradigms. Our expert speakers from Honeywell will soon share their insights on the topic and make the case for what their company does to make it all fit together. But before that, some quick big picture context from me. Whether driven by an energy transition away from fossil fuels and towards greater adoption of renewable energy, or to meet load growth in the dawning age of electric transport and, of course, AI data centers, etc., resilient and low-cost energy solutions are already in great demand. When we see the scale of change in the way power grids are supplied, drawn from and operated around the world, it may seem like large-scale battery storage would be the obvious answer to meeting many of those challenges. And for the most part, that's exactly what we can expect for many of society's and the economy's needs. So the next question is, why CNI storage, and where does that fit in to this new paradigm? Well, again, from the big picture perspective, CNI can be deployed quickly. It can be distributed, it can be smart, and it can interact with other distribution level or private network resources perhaps more effectively and nimbly than its front-of-the-meter cousin. But in a much more specific, customer-centric sense, CNI energy storage is an increasingly viable option for managing business energy costs, ensuring power quality for industrial processes, and preventing grid outages from having a material impact on productivity. In conversation with an industry contact last week at the RE+ trade show in the US, CNI storage was described to me as a value proposition that is actually relatively easy for customers to understand and relatively easy for technology providers to prove use cases for. Whoever it is that pays the electricity bills for a CNI customer would see quickly that a well-designed system could save their business money and at the same time enable higher consumption of renewable energy and lower consumption of expensive, more emissions-intensive fossil fuels, whether from the grid or via on-site generator supply or backup. Now, that's perhaps the basic premise in simple terms. Today's speakers can certainly talk us through what all of that means on a much more granular, precise, and detailed level than I can. So it's my great pleasure that we are joined today from Honeywell by Prudence Hoffman, Director of Business Development, and Adnan Khan, Senior Director of Offering Management. Their presentation will be followed by an audience Q&A session, so please do put your questions for Prudence and Adnan into the questions tab on the right side of your screen. We won't be able to tackle all of your questions in the live broadcast time that we have today, but please do rest assured Honeywell will be happy to follow up and respond in full and continue those discussions offline. Finally, from me, this session is being recorded and will be available in a few working days on the on-demand webinar section of the ESN website, along with presentation slides. And so with that, it's my great pleasure to welcome Prudence and Adnan. Hi there. And yeah, to hand over to our first speaker, to Prudence Hoffman. Over to you, Prudence.
Thank you, Andy, and welcome everybody to our presentation on adapting to the grid, exploring CNI energy storage technologies for flexibility and resilience. And we are pleased to be able to spend the time with you today. Before we get into the presentations, we will quickly introduce ourselves. So I'm Prudence Hoffman. I'm the Director of Business Development for Autonomy X at Honeywell Process Solutions. My role is to focus on go-to-market strategies related to energy advisory services that support decarbonization, electrification, and grid resilience. And I have over 25 years in industrial automation and energy controls experience. Prior to my current role, I led global teams as a portfolio director for integrated climate solutions. And I was also the global solutions leader for the energy storage team in process solutions. I have a bachelor's of science in electrical engineering from the University of Alberta. Yes, I'm Canadian. And I've completed executive programs at both the University of Calgary and MIT. I'm going to hand it over to Adnan to introduce himself.
Thank you, Prudence, and thank you, Andy, for a great introduction. So my background, about 25 plus years in the energy and automation business. Last couple of decades have been exclusively on the generation side of it, transmission and distribution side, developing microgrid projects behind the meter, in front of the meter, utility scale, CNI scale. I will be sharing today perspective from actual project deployment point of view and how the CNI customers are impacted and where energy storage plays an important role to that. So looking forward to this great conversation. Back to you, Prudence.
Thanks, Adnan. Okay, so let me walk you through today's agenda. First, we're going to look at the energy landscape today and what's driving the changes that we're seeing and where the pressure points are. Then we're going to dive specifically into the challenges that face commercial and industrial customers, particularly as the grid increases in its instability and we see energy costs rise. And from there, we're going to talk about the hero of our story, energy storage. We'll explore how it's transforming energy management and resilience, and then we'll wrap up with some information on our solutions in detail and how you can get in touch with Honeywell. So the energy landscape today, global demand is surging. It jumped by 4% in 2024, largely driven by heat waves, cloud computing, crypto mining, and AI adoption. And the future isn't getting any better. Demand is projected to more than double by 2050, making grid stability a critical priority. While demand is increasing, we are also seeing that our infrastructure is aging. The grid today is overloaded and it's outdated, and this threatens reliable power delivery without major upgrades. We also see a large adoption of renewable energy, and that is widely variable in terms of what it can produce. So they're essential, but they're inconsistent. And this makes balancing supply and demand quite challenging and makes the grid unstable. So this means we need advanced energy storage and smart grid management solutions to ensure that we have a stable, resilient power supply. Diving into some of the details, we saw that in 2024, as we went past 4% in global electricity demand growth, that meant that we were passing 30,000 terawatt hours for the first time. As I said, this was largely driven by extreme heat waves and rising digital infrastructure needs. The chart on the left on the bottom shows the annual demand growth from 2015 to 2024, and it also shows a post-pandemic strong recovery, but we're also seeing increasing climate-related consumption. AI's role is reshaping the economy. It's projected to generate $10 to $15 trillion annually, with generative AI alone contributing to $2.5 to $4.5 trillion. This has huge implications into the energy required. This economic surge demands massive power. Data centers will require an additional 50 to 75 gigawatts of energy infrastructure by the end of our decade. And on the right, you see the projected spike in demands from data center power consumption, and that really highlights the urgency of what we're seeing. So this is putting tremendous strain on our infrastructure and causing challenges from the grid. Transmission capacity must double to support renewables, but as I said, the grid is old and much of our grid is over 25 years old and in need of urgent upgrades. However, as upgrades require transformers, we're starting to see or expecting to see a demand in transformers to increase by 250% by 2050, yet there are supply chain challenges with transformers, and that is delaying deployment. We're also seeing a lot of changing weather patterns, and we're experiencing more weather-related outages, and these are increasing both in frequency and in severity, also causing grid instability. Wind and solar, as I mentioned, are essential, but their intermittency makes things challenging, and that makes it really hard to balance supply and demand when your energy is not consistent. So energy storage can be quite helpful here. Storage provides flexibility, it helps smooth fluctuations, and it strengthens grid resiliency. So alongside programs like demand response and using natural gas for firm supply, energy storage is key to a sustainable, stable energy future. What does this all mean for those of us that are consuming power? It means that our energy prices are climbing and becoming unpredictable, and this makes it very challenging to budget, especially for large consumers at facilities. Our aging infrastructure of the grid and the capital constraints that are limiting those grid upgrades are causing delays in grid modernization, and that introduces risks to us, like requirements to curtail our load and perhaps providing poorer quality of power. High solar penetration is also causing negative electricity prices. We've seen up to 12 times in the European Union in 2023, and also starting to see this appear in California in their winter months. So this makes planning extremely complex. These fluctuations make it more difficult to plan, and it increase operational risk for our customers operating commercial and industrial sites. So resilience is an essential factor. Facilities must prioritize continuity, safety, and power security. And it's no longer just an option. It's something that they must focus on today, and it's only going to continue to get worse as the grid becomes more unstable. So for our behind-the-meter customers, energy storage offers cost savings, backup power, and demand flexibility to help manage through this transition and the instability of the grid. So I'm going to pause here now and hand it over to Adnan to dive deeper into the challenges that are facing the commercial sector. Thank you.
All right. Can you hear me?
Yes, we can, Adnan. It looks like we might have temporarily lost your video, unfortunately, but your audio is coming through, I believe, loud and clear. Yeah.
Okay. All right. So okay. So we'll talk about the commercial and industrial side, the challenges that we have for the buildings. Buildings consume about 40% of the energy consumption out there, and there's a massive waste for the energy within the buildings. It's similar to having your cup of coffee in the morning, and then you throw half of your cup of coffee in the morning, and so rest of the energy. Buildings lag behind from the rest of the other technologies. AI and others are taking off, and the buildings are behind. Your schedules are the same. They're running on old energy usage. And then the grid intelligence is the future. When you need the energy, how much you need the energy, where you need it. That's what the future is. So smart buildings, your occupancy, energy usage, all has to be smart so that you can reduce the waste for these buildings. So it's not anything new. We're seeing this trend. The energy cost is increasing for everybody. The outages are more frequent, be it because of the weather events, be it for the grid congestion. The grid volatility is, we're all facing that. In addition, there are mandates and initiatives from organizations to reduce carbon footprint. So when we look at this whole aspect of that, it's not that you need more energy. It is that when you need to deliver it, when you need it, at what time, and use it more efficiently. So with that, we look at what the grid congestion is. Grid congestion. So utilities are facing a lot of challenges. They depending on electrification, depending on usage, temperature variations, growth, the utilities are implying demand response charges to the customer. Every 15 minutes, there's certain programs, certain regions, they're looking at your peak, that's what you're using, and then the rest of the year is determined by that peak that you utilize in a certain given month. The contractual limits, that how much energy to use, and that how much the demand charges apply there. That's the constraint. Time of use is big thing. Previously, grids have or utilities had certain 4, 6, 8-hour time blocks. Now what we are seeing is the time of use is switching to 1 hour, 2-hour tariffs there, so that they can better manage the demand. And then the building capacity constraints that if you want to expand the building or facility, add EV chargers, um, it cannot be served. The utility cannot serve that load there. So these are the constraints. So all of this is grid congestion. So grid congestion ties back into the T&D, what Prudence was alluding to earlier, that you have generation, we have energy, but to bring it to where you need it is the challenge. And doing T&D, transmission distribution upgrades, is very challenging. Takes time and years in doing those upgrades. One of the things that we are seeing is in the marketplace is the EV load. If you notice that, yes, the EV adoption is still not at the pace that was anticipated, but looking at the patterns of the EV manufacturers, they have retooled their factories, and they're coming up with the products, newer products. Dozens of models are available out there. So that means that the adoption is limited by the availability of this charging infrastructure. So the charging infrastructure is the challenge. Typically, these EV chargers are connected to the grid. So that means that you're again looking at the utility to serve those loads. But going forward with the smarter buildings, the EV chargers will be connected to the building. And now you have this significant load, but this is a smart load because it can also share the energy stored back with the building. So looking at that chart, that from the beginning of the day to the end of the day, that how the EV charging impacts that load. And it could be significant. It could be 2, 3 times the load of the actual building. So it cannot be ignored to do that. And also is that the customers demand being able to charge their vehicles when you go for shopping, your preference on that. Employees are asking for the employers to have these capabilities available. So this is something that we need to address that, and the buildings play an important role to support this load, especially with the two-way features that are coming in the near future. So the behind the meter energy storage serves these loads. So if you're depending on the grid and the grid cannot provide the power, how do you do continuity of your operations? So reducing the peak load, taking these battery storage or storage systems, and then serving or putting the energy back onto the grid, uh, making that asset as a revenue generating asset there to that serve your load as reducing the expenses there. So cost cutting, serving, participating in grid programs, energy storage offers all these aspects there to as a virtual power plant and stuff to serve that. If you are looking to like as if you have a electric fleet and you want to add that into your operation, and you go to the utility provider and they say, sorry, we cannot provide that, behind the meter storage allows you to be able to serve your needs on the electrification and the load needs. So this is some of the use cases. Anytime we talk about energy storage, we always talk about the pancake approach. So these are stacked. The visuals on the right side do not necessarily indicate that they are higher value than the ones on the left. They just indicate that this is a stacking, increasing value with multiple values to be able to do that. So looking at the grid resilience, grid reliability, that's important. Automatic demand response, that the systems are looking at your demand and doing that, reducing your HVAC, building lighting, and such. Then you have the peak shaving aspect of that. We talked about for the energy storage, vehicle to grid, a V2X, vehicle to home, all these aspects there that can help with these challenges. And then we talked about the carbon footprint, that if you charge the batteries at nighttime, and the value of that energy has lower carbon footprint just by sheer nature of it, because during the daytime, the peaker plants are put into place to serve the grid needs. And at that time, you're adding much more carbon footprint. So if you utilize the energy that you shared or you saved from the night before, or from the time that where these peaker plant or simple cycle plants were not running, you automatically were reducing the carbon footprint from your energy usage. So this is a little bit of a busy slide, and it also is indicative of the congestion or the complex landscape that you see out there. So just to understand this, we'll just break this slide into half. So the right side of the slide is indicating your supply side, energy side of the equation. You have different assets. You may have one or the other, from grid traditional plants, backup genset, solar PV, all that. And on the left side are the loads for the building. You see boilers, chillers, pumps, elevators, lighting, EV charging. Buildings have building management systems. They're quite complex and very capable to manage their loads. So they will look at that, what the usage is, what the comfort settings are, and they will curtail those loads looking at that. But they're totally dependent on the grid to support and provide those loads. If the grid is not there, all that automation optimization does not help. If you look at on the right side, where the grid is coming or the plants are coming in, and if that supply is impacted, then the buildings or the loads cannot be served. So you develop these on-site generation assets, behind the meter, CNI, all these assets. And if there's no communication between the loads on the left side, demand side, and then on the right side from the supply side, they're working blindly at each other. And so the loads are expecting that whatever load I have, these generating assets are going to serve the load, and the energy side of the equation is thinking that, okay, I'll just wait for the load to increase and I'll adapt to it. So it's responding to the increases, but they're not necessarily communicating. What the future is, what the buildings, what is that it's the orchestration of the energy side of the equation and the demand side of the equation. That's where organizations like Honeywell come into place, where we're like a conductor there, and hence the word orchestration, that the buildings look at that, that, okay, this is what my load profile looks like, and they communicate with the on-site generation assets, or look at the rates and say, what is the state of charge of the battery storage? I'm going getting a cloud cover, or what? Do I have resiliency issues? Is it a bad weather coming up there? And basically tell the generating assets that my usage is this at the moment, and the generating asset communicate back and say, my state of charge is this at the moment, or I was not able to charge, or this is what the current status is of a cloud cover and such. So the building management system goes back and optimizes those loads. So this communication between the two sides is very important to do that. Otherwise, each side is operating blindly. So when you look at this, what is the most complex part? And this is coming after, having been developing a lot of projects, is that each of these systems by themselves are very capable of doing that. But when you put them together, the most important aspect of any of these projects is the integration between these assets. That's where you need a experienced partner like Honeywell that can come in and understand that how these systems will communicate with each other. We develop controls, complex automation systems, and basically is communicating there. So you look at this and you optimize all these assets, looking at historic data, and you deploy that. And then in real time, you continue to optimize based on the needs to do that. So This optimization can serve you reducing your utility bills, peak shaving carbon, and essentially making your assets much more valuable than if they are independently operating in isolation and just looking at that, okay, what's my next demand going to be versus planning ahead of time and intelligently communicating. So it's the orchestration between the demand side and supply side. These smart buildings with these huge loads will be serving and implementing there. With that, I will pass it back on to Prudence.
Thanks, Adnan. So we heard Adnan talk about the challenges that the commercial market is facing. And so these buildings are facing rising energy costs, unpredictable outages, and demand spikes. But industrial sites face even more complexity. Industrial operations are high load, they're continuous and mission critical, making them highly vulnerable to grid instability. And instability in the grid leads to power outages, and it also leads to power transient events. These are brief but disruptive fluctuations that can trip systems, damage equipment, and halt production. And these aren't minor issues. They pose real financial and operational risks to the industrial sector. So our industrial customers are shifting their conversation from energy supply to energy stability and control. Facilities must invest in infrastructure that can anticipate, absorb, and respond to grid dynamics in real time. So what are the details of the impacts of these grid instability? It causes operational disruptions. So transient events can trigger unplanned shutdowns. This causes downtime, lost productivity, diverts resources to deal with that unplanned shutdown. It can result in loss of revenue. Interruptions lead to missed deadlines, delayed deliveries, even penalties if you're not meeting your customer contracts requirements. This can damage trust with your customers. It can damage your financial performance. Outages and power transient events can also cause product and safety risks. So poor power quality can damage the products. If you think about the semiconductor market, if you ran that product through a poor power quality event, you have to throw that all out, which is a waste of materials. It can also create hazardous conditions for employees at that site. Sudden shutdowns or transient events can cause wear and tear on your equipment. This leads to costly repairs and in some cases, irreversible damage requiring replacement for that equipment. So it can be quite serious. So we're looking at our industrial customers now looking to be proactive in how they manage their energy as an essential action to minimize disruption and maintain safe, efficient operations. So now I'm going to talk a little bit about how energy storage can support both the commercial and industrial sectors. So energy storage, such as battery energy storage solutions, offer a nice fix for these problems, right? They provide operational flexibility, resilience, support cost savings. It can be quite helpful to have that flexibility with you at your site. So I'm going to now explore some case studies that highlight two examples of where energy storage was addressing power outages and resiliency challenges. So let me just move on. The first site we're going to talk about is a life safety manufacturing facility of Honeywell's in Lugoj, Romania. This site was facing recurring power outages due to the instability of the grid and severe weather, severe winter storms. These frequent power transient events disrupted operations, was damaging equipment at that site and causing a lot of waste in terms of the product production materials. So Honeywell worked to provide a hybrid microgrid solution. This was a solar PV, rooftop and car part solution combined with battery energy storage. We upgraded the diesel generators at that site. And then just as Adnan was speaking in terms of the supply and demand orchestration solution, that was what we supplied to that site as well. So there was the Honeywell Ionic control and energy management platform managing the microgrid and the power manager application sitting over top of the building and the microgrid to balance supply and demand at that site in context of what the grid was doing and what the weather forecast was going to be for that day. So in short, the system connected with SCADA at the site, microgrid controls, and the building management system to provide a coordinated energy use. And so what were the results, right? So that site saw improved grid reliability and power quality issues. They were able to solve for that problem. They had full backup capability during the outages. They have a reduction in their daily electricity consumption and utility costs. And as this was one of Honeywell's own sites, switching to a solution that maximized solar energy and reduced waste of product materials, that supported us and our sustainability goals, right? And of course, it lowered our import costs, right? So the Lugos microgrid shows how we were able to integrate energy systems at that site to boost resilience, cut operational risk, and drive long-term efficiency. So the next study that I'm going to look at is a particular solution for our oil and gas customers, mining customers that rely on spinning reserve to maintain operations, right? So these sites often have high resilience needs. And so they're running these turbines at all times on backup because they just cannot afford to have any interruption in their supply at all. These turbines often run at low loads, less than 40%, which can lead to inefficient fuel usage. It can lead to high emissions. And of course, there's runtime hours, unnecessary runtime hours on these turbines, which is causing to wear and tear, right? And why do they do this? That's because when a turbine's in cold standby, it takes about 20 minutes to start. So facilities just keep them idling so they don't have to wait for those 20 minutes. And that consumes fuel, and those fuel costs can be about 80% of the operating costs. Even if the trips are rare, the facilities are willing to absorb that cost because they cannot handle a disruption in power in any way, shape, or form. So there's a problem with efficiency. Of course, if you're running these turbines at low loads, especially those who have low NOx burners with them, so they're burning fuel inefficiently, and this ensures that they require frequent maintenance. So how can energy storage help here? Well, an energy storage system can respond in milliseconds. It can replace idling turbines and allow the turbines that are running to run at optimal efficiency. So you would integrate the BESS with the existing systems at site. So the integrated control system, the DCS system, the SCADA system, the power system, whatever is there at that particular site. And our energy management system is vendor agnostic to those systems, so we can connect into whatever is there, right? So what I have on the slide here is the results from a study that we did for Petronas Malaysia. This site was running 3 turbines at 40% load, and the site load was really only 56% of one of the turbines. So we did a study, and the result of that study was that we proposed to 4.6 megawatt hour energy storage systems for 1 hour duration. And this would enable the shutdown of the extra turbines and increase the efficiency of the last remaining turbine that was supporting the load. So the study showed an expected result of $40 to $45 million in savings over 15 years. This includes carbon credits that Petronas Malaysia would have received if they implement the solution. It had a payback of under a year and a half. It had a greenhouse gas reduction of 17%, about 22,000 tons of greenhouse gases. The fuel usage is expected to drop from 16 to 13.3 gigajoules per megawatt hour. And due to the lower runtime hours of those standby turbines, 33% fewer runtime hours, we were expecting to show 50% lower maintenance costs. So the takeaway here is that an energy storage integrating with a turbine system and replacing spinning reserve and placing those turbines onto cold standby boost reliability, efficiency, and sustainability at that site. So it's a smarter safety net for an industrial power. And a solution like this is scalable across upstream, midstream, downstream operations. And we do have customers that are deploying the solutions with Honeywell today in the United States. So that's the end of the 2 case studies that I have. I'm going to hand it back to Adnan right now, where he's now going to dive more deeply into the specifics of Honeywell's solutions. So thank you.
Thank you, Prudence. So let's take a look at Honeywell Solutions and what portfolio we have developed for a variety of market needs. As a global organization, we serve different markets. So each market has its own characteristic. Within even United States, there is different ISOs. They have different characteristics, different tariffs, different needs, different level of congestion to do that. So one size does not fit all. Um, so what we have done is that we looked at that there's a smaller size, that all-in-one type of solution, and actually you will see that this is what industry is pivoting towards as well. The RE Plus displays were quite indicative of this, because previously you had a DC block that would come in, then you had inverter, you connected to it, and then you have the balance of plant coming in put all together. Now the industry is shifting towards, unless it's a utility scale project, is all in one containerized solution. So very similar to what Tesla offering is, or quite a few others are, that everything is put together. You drop it at site, you make the connection. It's a quick deployment on site, and it saves time, and also the commissioning and bringing it to live. So if you look on the right side of the screen, that essentially is, smaller system, less than 1 MWh, all in one box, about 10-foot container. Then you go into 10-foot container DC blocks, modules put together. That also enables the modularity to do that. And then you go to the utility scale, which is 20-foot to 40-foot to 30-foot containers of that. So what the current trend is, that all those 20-foot containers, 30-foot containers are coming up with all-in-one solution. So essentially, just taking that small all-in-one box and making it bigger. If you have been following the industry news, on a 20-some foot container, you can pack anywhere from 5 to 7 MWh. I remember a time air-cooled units were 40-foot container was 1 to 2 MWh, and this is not that long ago that we had. So essentially, this market shift is going to make the battery deployment faster and quicker. More of the work is done at the factory level, and to do that. So that's essentially just on the battery storage aspect of that. Um, all these systems are standardized. I remember a time that you go to a different AHJ, they had different requirements. They didn't know whether we need to have a water sprinkler system or not. Do we need to have a dry pipe outside coming from the hydration, the place that to pour that? Is it going to create toxic? A lot of these things have been standardized. If you look at in the RFPs, the UL 9540A, the safety, the NFPA 855, all these standards are there. So anybody that is in the marketplace offering these solutions, they have to have these standards. So this is a great development on the industry, that everybody has to play on the same level playing field for the safety of the system, and also being able to talk from the communication protocols point of view, and to do that. So we saw in the earlier slide on the left side, you see all these generating assets, that to do that. So the epicenter of the demand and supply that we talked about, it goes into the analytical services. So whenever you're looking at a project, the most common feedback when you talk in the industry, customers, whether it's our customer or what we talk to somebody that we're trying to help them, what they find out is that they wish they had selected a different vendor. And so you wonder that why that is. It's the education, it's the analytical services. It is not to sell a product, but it's understanding customer needs, what that is, and being able to customize that solution to serve their needs. If a customer already knows what they need, they'll just go and get it. It's just like, if you're sick of something, you just get the medicine and just do that. But you go to the doctor to go and figure it out, that how are you going to solve this? So that analytics is very important aspect of that. So we take a consultative approach for end-to-end solutions. Honeywell offers, where we engage looking at the historic data, and I think some of these established solution providers in the marketplace, they take a similar approach. But I'm saying is that you have to think that who do you select to do and help you with your project needs or address your challenges there. So when you look at the solution approach, end-to-end and consultative, it's the initial desktop analysis is very important. This is something that can be done utilizing some sophisticated tools of optimization, looking at your energy usage and stuff. One other thing was in the service was mentioned, which I always thought that, well, that's what you should do anyways, is that um, that looking at your loads before you deploy any generation side, on-site, battery storage, any of those, you want to make sure that you have optimized your efficiency on the load side of it. So um, LED upgrades, lighting upgrades. I mean, I don't know if there's anybody that's still left that hasn't already done that, but looking at the chiller optimization, looking at the smart sensors application for conditioning of the space, airspace, that if you're not using it. So deploying those efficiency measures on the building is first and foremost, because before you determine a energy solution, you want to make sure that your load is fully optimized. Otherwise, you'll be sizing for a system that you don't need. So you're oversizing it and such. So that consultative approach from the beginning is very important to understand what the needs are. And that's from there that you look at that, okay, what is the customer's objective? Is it the ROI? What is their hurdles? Is that how the project will be financed? Look at that. So those aspects, that what that timeline looks like. Another thing is that I think, I mean, like we talk about that, why is it taking long to do a project or interconnection? I'll give you the perspective from the utility side of it. I've worked with them quite a bit, and it's not that they're trying to be difficult. They have a huge challenge on their hands from the grid side, because think about it, that you want to deploy an asset that is connected on their system. They want to make sure that their operations are not interrupted. Secondly, that if you want to draw more power from your transformer, even if you upgrade the transformer, I mean, if you have a 1 inch pipe coming, water pipe coming to your house, and if you put a 2 inch outlet at the end, it's not going to improve anything. Your limitation is on that power coming in there to that. So when you backtrack from there, you have to go to the local substation. So you have all this distribution yourself and other customers, and that are also trying to add load at the same time. And then you go back to the substation, and from substation you go back onto the grid with the high voltage transmission lines. So when you go for an interconnection, this is the biggest unknown and biggest challenge in any of these projects to deploy, is that if it's an islanded system, great. If you could do that islanded microgrid, you're not connected to the grid, you can go ahead. Your constraints are the lead times on the equipment, and you can do that. But when you look at a grid connected system, you have to ensure that you're not going to add any harmonics, any additional noise back onto the system, and being able to do that. So this interconnection process could be quite tricky, especially when you're looking at grid services programs that you're going to participate in the grid, demand response programs, monetize these assets. So for example, if a utility offers that you can deploy a 2 megawatt battery storage system, but your site load is only 500 kilowatts. And if you're going to deploy a 2 megawatt system there, that means that you're going to push back about 1.5 megawatt of power back on the grid. But if that transformer was never sized to take that power back to the grid, that's your first constraint. Okay, we got the transformer somehow. I'm like, given the lead times or something, or somebody had it, or whatever the sourcing is. But now the challenge is not ended there. You can't just go ahead and replace the transformer, because you have to study all these electrical circuits all the way to the grid, because it could create problem down the road. So these aspects and planning for these aspects and is very important. I've had clients where they said, we're ready to deploy battery storage now. So if somebody comes in today, says that to me, I'll think that they're looking at next year summer timeframe that they want to deploy that. No, we want to deploy it right now. So even if somehow somebody has a battery storage sitting around, like within a few weeks or something, they can give it to you, you cannot deploy it because of the interconnection, because of the challenges that I mentioned. So So the trend that what we have seen is that the utilities, it's a big shift. Previously, where utilities were okay, they are very collaborative. They reach out, they look at, and especially with these huge data centers, that how to collaborate with them, because any of those changes makes a big issue for the grid. So it's better to partner and collaborate there, that how to go about this. So looking at the center of it is the control and energy management aspect of that, to deploy these strategies, that what is the optimization of the load, optimization of the energy, that usage that you have, and then also these assets to be deployed. So this is a sum up of that as a solution approach, as different grids, different regions, Honeywell can help customize this solution. To do that, we have services, operations, offices globally, that we can serve that. So it's one entity to go to. You don't have to worry about behind the scenes, that what the interfaces look like, how the solution is going to come together, integration aspect of that. We will take care of all of that. So I just wanted to spend some time that where most projects fail or get into trouble or do not deliver is that upfront work, the optimization and the analytics, and also understanding and setting the right expectations for the customer. What's next, you may ask? So this is essentially resilience is a big aspect. I know it's listed at the bottom here, but grid stability. I mean, like energy storage is not in the order of importance, but these are all the aspects that are impacting today's grid.
And seems we may have lost Adnan's sound as well as video now.
Okay, so can you still hear me?
Yes,
Yes,
you're back. You're back. Yeah.
Okay.
Great to have you back.
Okay.
Yeah.
Apologies. I mean, like after the best efforts on the technology, it still remains a challenge. But anyway, so trying to
These
sum
things
it up
happen.
there, that
Fine.
when you're looking at these renewables, looking at these inverters, they're all creating harmonics. Of course, they are certified, UL certifications, IEEE certifications, all these aspects are there. But they create power quality issues, end of line. You cannot deliver these the energy. And if you have microprocessor based electronics on your campus, they're getting impacted because of that, because of the intermittency of the renewables, lack of the reactive power in these electrical circuits. So all of these challenges, the aspects are there that are creating that. Battery storage provides a lot of those solutions to it, because it can inject the reactive power. It can operate in all four quadrants. For those, it's reactive power and real power quadrants that it can operate very quickly. It's ready on demand, deploy that on almost instantaneously. So these features, key inherent features that no other generating or storage asset has, or technology has, is the energy storage, battery energy storage, that addresses these challenges that are there. So C&I customers behind the meter, you're looking at battery storage to be able to solve that. That's why, just to add that, in this latest policy that was rolled out not too long ago, battery storage got a pass, that because it helps the utilities, it helps the customers, it helps with those needs that to continue solve for the grid congestion and reliability and add resilience. So with that, we'll open up for questions.
Excellent. Thank you so much, Adnan and Prudence, for your presentation. We do have a few questions from the audience, and we have about 10 minutes to answer them. There's a couple of things I wouldn't mind having a brief discussion with you guys about that I'm quite interested to learn. Before we go forwards with that, though, I think we could exercise a little bit of Honeywell's sponsors privilege, I suppose, and show a pop-up for the latest product, being the all-in-one battery energy storage automation platform that Honeywell, I guess it must have been in the works for a while, but the announcement came out last week. So on our back end, Lois, if you could pull that pop-up onto the screen, and the folks can can click that link, and there we go. So you can follow that. While that's up on screen, we do have some great questions in, as I said, from our lovely audience. That said, you do have a few seconds left to get questions in. In fact, I do want to say that if you get your question in now, we don't get a chance to respond to it in real time, then of course Honeywell will be able to respond to you offline in the fullness of time. So with that, without further ado, yep, still more questions come in. Fantastic. So let's start from the beginning, as it were. So question from Virginia. Thank you so much for your question, Virginia. Virginia's question is goes back towards the beginning of your presentation, Prudence, on the transformer shortages, which have been obvious for many years, and why has the industry not corrected this problem in the supply chain? Are there inherent difficulties in producing transformers and inverters? And I guess, if I may, and frankly, no one really asked me this question, but my take on it from what I've heard is that you don't really mass produce transformers and put them in a warehouse waiting to go to large sites, right? So they're kind of made to order. So that makes things tricky. People are now investing as well in, big transformer factories, but I guess that's going to take some time. But yeah, so maybe not directly to go into this question itself, Prudence, unless you want to. But yeah, just that dynamic between how quickly you can deploy things CNI without transformers, and just that whole, the dynamic of transformer supply chain and where that fits in with today's topic, I guess.
Yeah, I don't have an answer. Not being a transformer manufacturer, I don't have. Honeywell doesn't really have an answer for this. We are, living with the consequences of that shortage. My guess, and not being a manufacturer, so I don't have the informed answer, is that I think demand just started growing a lot more quickly than the supply chain anticipated, and then you have a lot of geopolitical changes that are happening at rapid pace, as well as to where things are going to be manufactured and where they're going to be shipped. And I just think it takes time to catch up with demand, right? And there's lots of, not only are the CNI customers competing for those transformers, you have the transmission and distribution industry competing for those transformers and that manpower, and just the metals and the materials that go into it. So I just think it's just all of a sudden everybody needs them all at once. And yeah, it was obvious, but not always. We don't always take action for the obvious things until the pain hits. So yeah.
I'll
definitely.
just add a little bit.
Oh, sorry.
I'll just add a little bit to it. I mean, like that, because I come from, like, we do projects. My whole career has been doing projects, and theoretical aspect is one thing. I'll give you one example for Ohio market. One of the projects that some in the recent past we were looking at these constraints. In last 150 years, certain Ohio market had 75 gigawatt of load. In last 4 years, 60 gigawatts of load has been added to it. So that's the challenge. Now you look at these mega scalers. These mega scalers are looking at 1 gigawatt or larger systems, and these data centers are popping everywhere. It's not just the transformers, looking at the backup gensets, the turbines and stuff. Next 3 years, 4 years, the supply is sold out. Now, how do you balance that out with that? Is that everybody wants to have the AI all implemented and stuff? So the growth rate, nobody anticipated that this rapid growth. We were doing okay, but when this with this data centers and AI usage, that has taken it off exponentially, that it was in nobody's sight to do that. So that is a tremendous. And if you look at the manufacturers, they are ramping up. I mean, somebody that had 3 factories, now they have 10 factories that they're doing that. So, but the demand is tremendous. It is tremendous demand. So it's if you take this data center and this load that has been added to the grid out, yes, the ramping up has been actually more than what the needs was, but because of this load, it seems like that we don't have enough of that of those transformers. So just wanted to add to that aspect. It's a point that you have to be very cognizant of, that where you do that and where the supply is going to be looking at the new rules for tariffs and stuff, that also puts additional constraints that we're going to source this equipment from. So
Yeah, absolutely. And you know, from my understanding, it's at the end of the day, it's not just as Prudence says, it's not just energy storage systems that need, you know, they'll be looking for these transformers. You're competing with everything that's being added to the grid, be it, you know, renewables, thermal generation, or what have you. But yeah, okay. Moving on, there's a great question that's just come in. So Eric, you left it a little bit late with your question there, but I really like this one. So I hope the speakers feel the same way. So thank you for your question, Eric. Eric asked, is there a comprehensible solution that can be integrated to evaluate a CNI customer's load profile and all the equipment contributing to the load? Can this solution evaluate real-time loads and offer the engineer an ability to forecast future load profile changes? So I guess this is a question kind of about both the project design and sort of ongoing operation and optimization. So I'm not sure who wants to take this first, or indeed if either of you do want to take it. What do you think?
I'll take that. I mean, like there. So this is very important. This is actually the backbone essence of any successful project. Some examples. I mean, like I've, you know, in the past, some projects have been deployed that at the end, this part was not jumped into or like looked into carefully, and that resulted a lot of waste and unmet expectations. So that's why it's very important to take the time to do this analysis. So you may have heard the term digital twins. So digital twins is a concept. It's some have tried to actually trademark it, but thankfully it didn't, and it's a term that in the industry. So digital twin is essentially creating your virtual model of your facilities or the factory for what that is. So essentially you can go into simulation mode, you can see that how these loads are going to get. These are not, and this digital twin process will vary from like a food and beverage processing plant to a school. It is, you can still have a digital twin, but the tools that will go behind the scenes to optimize that or to model that, so that's there. So then you can run these environments into and using electrical tools for dynamic modeling and such. You can deploy that how those are. After you come up with an optimized dispatch model for the given assets and on-site generation assets and the loads, you can have that done dynamically. Now, dynamically could mean different for different industries. If you are in a data center or something, you want everything like without a hiccup, without like sub-millisecond like response. There's no. You go to another entity where a few seconds delay is okay. Others could be few minutes of delay. So digital modeling, a digital twin modeling will depend on how you optimize that. If you want to go ahead and deploy these seamless transfer technologies or something, that could be an overkill. So that's modeling, and now there are tools available for doing this optimization, energy management system that are checking every few seconds, every few minutes, and then going back to the system and saying, okay, this is the new setup happening. Go ahead and do that. You can have fisheye cameras looking at the sky, looking at this cloud cover coming in, and you can prep your system, get a 15 to 20 minute advance notice of this trend that's coming in. So the tools are there. Optimization, you need to find the right capability partner, and also ask these questions up front that how would you adapt to these changing needs? Tomorrow I add something to my assets here, load wise or something, how flexible this modularity is. So these are the right questions to ask. And thank you for this question. And it's great to hear that this is very important for the project development phase of it and operations down the road.
Sure. Any thoughts to add on that, Prudence, or should we go on to the next one?
No, Adnan covered it quite well. In the industrial space, of course, if you have a large industrial process like a refinery, or perhaps you're in the renewable fuels industry or looking to be in that industry, there are plant-wide optimizers that are looking at this as well. So in addition to, so if you think, I know this is still very much in the future, but green hydrogen plants, right? They are wholly dependent upon the carbon footprint of the power that's feeding into that site. And so we have plant-wide optimizers that are looking at the product carbon footprint of the product, the carbon footprint of the power going in, and adapting the process in real time to what's available. And that's Honeywell's strength in process control and automation, and understanding our customers' processes and being able to adapt them to the current operating conditions, right? So we can go into that in detail if they want, and we can arrange a connection with our experts. Yeah.
Excellent.
Okay.
Thank you very much. And we had a question in from a couple of people actually on financing, but the first person to ask that was Yujia. So thank you for your question, Yujia. Yujia was asking how these sorts of projects get financed, but I think if we can, pull that out into a slightly broader sense, I mean, I think what we always hear is, is obviously there's amounts of, huge savings. I mean, I think the savings for the Petronas project you mentioned pencil out to, at the lowest, most conservative point, something like $2.7 million per year based on those numbers. But obviously there is a capex cost associated with equipment, and people have to make decisions around investment. Now we've been hearing for some time, for a long time, the CNI space was kind of predicated on storage as a service and shared savings models and things like that. So just wonder, firstly, what in general principle terms, like how you see that balance between calculating the savings and what a customer might have to invest, pay up front, however you want to put it. And then, of course, feel free to tell us how Honeywell kind of approaches that situation as well, I guess.
Sure.
Yeah. And then did you want to take that? Yeah.
Yes. Yeah, because I mean, our group is a solution-based group. So after your initial consultation, very important part in the same session is that how are you going to pay for it to the customer? Yes, this is what you want, but how are you going to pay for it? Okay, so they may have some idea that they want to invest capital, but they usually keep their capital for their facility upgrades and their production aspects of that. So we can bring financial partners to the equation. It just depends that what the payback looks like, who's taking the risk, what is the market risk like, is it risk sharing model. One thing is that's what's the shift is happening is that previously the market was, or the projects were cost savings. You're looking at shaving your peak, you're doing those aspects of that, demand charge reduction and things like that. What the grid and the programs that are coming up is monetizing these assets where your cost center becomes a profit center. So you generate revenue from these assets by doing grid services. We talked about the grid congestion earlier, so grid ancillary services. So if you take this battery storage, for example, asset, and then you're doing your peak shaving and demand response, you reduce the bill. What if you size it such incrementally that in the event of a grid congestion or need, the utility sends you a signal, demand response signal or something where you curtail the load all you could, but now you can inject the power back into the grid to relieve that congestion. That goes back to monetizing your asset. So where your payback was, let's say 5 to 7 years, now your payback is 3 to 5 years. I mean, like there to that. And when you look at what we'll see more and more is that the frequency issues that the grids are facing. Previously, it was pre-PGM. Now it's ERCOT, MISO. Other areas are facing these ancillary services. So the utilities are coming up with these incentive programs as part of the overall financial model. You have to look at what grants are available, what your savings are going to be, but also how you can monetize these assets and have a quicker payback by participating in these programs. That's why that takes a different approach. That takes a proactive approach. That now you have to push power back onto the grid. The electrical design is going to be different versus you doing everything behind the meter. So these are the aspects that are allowing some of these projects that would not pencil out previously, but now they would. So several states have these incentive programs are they're coming up with these policies that will allow deployment of these assets more favorable.
Excellent. And yeah, I mean, we did actually have a question on the regional incentives for CNI storage and solar. But I don't know that you perhaps did already somewhat cover that nicely in your previous answer just then, Adnan. But Alpa did ask where some regions with favorable incentives for CNI solar and storage are. As I say, you did just recap that for us quite nicely, but are there any other things you could add in terms of the principles of what people should look out for? Like perhaps if they're not in the US, or even if they are, like, you know, some of the, yeah, I mean, some of the things they can look out for, and perhaps some of the ways that those programs are evolving, I think might be an interesting thing to tackle if you would.
Yeah, so briefly to touch upon that, great question actually, by the way. I mean, so we commonly, look at the US market, but as a global organization, we have customer install base all over the world. Our systems are installed, building management systems and such, industrial customers there to do that. The rest of the world, if you go to Europe, like the whole country will have one grid code, which simplifies things there to deploy. Also is that some of the policies that are impacted, financial policies or tariffs or something that a business here may be subjected to. In other regions, they may have flexibility to utilize sourcing when they're not exposed to those financial challenges to do that. So each region will have this aspect different there to address. That's where a knowledgeable partner to come in and guide through those. You will have different incentives available because of the different challenges. I mean, if you go to Europe, like this DC transmission systems are so prevalent that we don't have that here. I mean, they're looking at it now in transmission systems for its own benefits and stuff. But when you look at that it's very important to understand the geographic regions. I think just to answer the question on that, which markets you would focus more, PGM market, the congestion, the northeast side, just by the sheer population of that, and then the aging infrastructure, that you can't just go ahead and deploy these enormous or expand on the transmission lines. They have a huge challenge. So when you look at 900% increase in charges from PGM, that is not a coincidence, because they have this problem. These power plants have been shut down because of one reason or the other. Now the power has to come from farther away. These congested nodes are causing that issue. So that's there. I mentioned, I think earlier on ERCOT market, it was very stable. It's like, okay, previously, but now we have seen the events that happen in ERCOT market. The characteristics are different, but they're coming up with also grid ancillary services programs to participate in, behind the meter, in front of the meter, customer sited programs. We're seeing more and more of that. MISO is coming up there, not to the extent as PGM is, but you're seeing more and more that in the Midwest, where the PGM area extends all the way to Illinois and Indiana, like on those areas, Ohio, a similar congestion is being noticed. So that's where if you're looking for opportunities, or if you're looking if you have facilities in there, that's the aspect to deploy that.
Yeah, it's a really exciting dynamic, I think. I mean, something like you could say 10 years ago, it was almost exclusively, or certainly the things that we were being told about by providers was almost exclusively California. It was almost exclusively around peak shaving, and, you know, some combination with the self-generation incentive program for solar and, you know, things like that. But it seems like it's really broadening out, and, you know, it's great to see that happening, yeah, in other parts of the US and other parts of the world as well. So I'm conscious that we've gone over time, but if you will, I'm enjoying this quite a lot, and I hope everyone else is too. So could we just do one more question and then we can wrap it up, I think. So there were a couple of questions around duration. So Ken, thanks very much for your question. Ken's specific question is, what is the duration at rated power of the ionic BESS solution? But also, I guess if we could just, you know, rather than just talking product directly, although you're welcome to do that, I think some flavor of how you model these durations and perhaps, broader hardware questions? Like, for example, the Lugoi Romania project and the other one for Petronas, those are 1 hour duration batteries at a kind of rated energy to sort of the power match of the solar. Then you've got other things, interacting with that. So how are we thinking now about how you plan the duration of these projects and just modeling and designing things in general? And I don't know which of you'd like to take it first, or if you'd both like to chip in, but yeah, it seems like a good one to finish with, if we may.
I can take that, because I think it's going back to the technology and the evolution of the technology, that how it has gone. So if you take just a step back, that how it was. So it was, California was the energy market, and then the East Coast was the power market. So it was a smaller system, fast responding, high C rate systems versus low C rate. So when you look at these, just as an observation, when you look at these utility scale projects and stuff, interestingly, they're all about 4 hours there. So that's your 0.5 C rate. I mean, like, somebody understand that the C rate is that, okay, how much energy you can provide for how long gives you your C rate there to do that. And then so slowly these power systems, the utilization of that has slowed down quite a bit. And it seems like the industry has standardized, if I have to pick one duration out of all of them, is 2 hour solution. So between 1 hour and 2 hour solution, some 4 hours also. So between, if I have to have the range, is between 1 hour and 4 hour. So 2 hour and 1 hour chemistry is very close. We're talking about LFP technology. I think somebody had a question about electrostatic aspects of that. So when we look at these technologies, you have to also consider the commercial viability of these technologies, what that is. Anybody that's doing that, because if you're going for financing, or even if you're paying as a capex yourself, you want to look at the technology that is financially viable, commercially viable, that you can finance it, and also it is serviceable. Some new technology comes in, it has not been vetted, has not been deployed there. Do you want to be that serial number one to be able to deploy that technology? But the technology is moving very fast. If we thought that the PV development or improvements in the industry was fast, battery storage has left that in the dust. It is the fastest. I mean, we had projects that we put the solution together. By the time we went to deploy it, implement it, the technology changed so much that we had to go and redesign the whole project because of that. We currently have projects that we're just implementing these battery storage, but the next wave of that is the newer, higher density projects to do that. So this shift is going to continue. The next aspect everybody is looking for is the solid state batteries coming in with the much higher energy density, and the degradation sodium batteries are there. Like I said, in my career, last 15 plus years working with batteries, there are technologies that have come and gone, and it'll continue to do that. Main thing is that you look at these, you work with a partner that has been around a long time, because their backward compatibility. A lot of companies have come and gone. I've actually lost the count of the battery companies that came in and gone. So working with a partner that can take the commercially viable technology at that time and maintaining that platform for times to come, and later down the road, 5 years, 10 years down the road, providing the O&M guarantees like we do in our projects. We can offer 20, 25 plus years of guarantees and performance and stuff. We are taking that risk to deploy that and make sure that it's backward compatible to do that. So that's where it's when you're going for race to the bottom line on the cost versus looking at these future challenges that you are going to face that. Nobody's going to have these similar batteries in stock or anything like that. So how is the new battery going to go back into it? How do you put that separately on the AC side? Look at the deficiency of the system, just put that, and how do you go about it? Sometimes we had the projects where replacing the whole container was more cost effective than going and trying to replenish the batteries, the older technology batteries. So I hope that answers that question from the duration side and technology side. This is something that is a moving target. You have to be agile. Our customers expect us to be agile. You want to work with these technologies partners that are looking at that. What's the most viable and commercially feasible technology to deploy?
Yeah, I'd like to just add to that too. The controls platform is agnostic to the equipment. So yes, Honeywell has ionic energy storage solutions that we sell, and of course, we want to sell you our battery energy storage technology. If you have an existing energy storage installation at your site, we can connect to that. We've connected to all sorts of brands. When we were deploying or building out our controls platform, so the Honeywell Ionic Controls and Energy Management Controls platform is based on Honeywell's legacy process controls and automation. We've been in that business since the inception of automation and process control, and we purposely built that controls platform for this market to be agnostic to the generation equipment, right? So as that generation equipment evolves, so you move from lithium to salt to solid state to those small modular reactors, just whatever that future technology is going to be, our platform is agnostic to that, right? So of course we have tight state-of-the-art integration with our own technology, but we can connect to other things as well and still deploy our algorithms.
Great point. If I could indulge just for a brief moment here, great point, Prudence, that you brought, because in our recent user group conference, this was mentioned there that Honeywell, with all our products, have been made where it's not proprietary. Because if you like a certain solution from somebody, you should be able to integrate that into your platform. So to what Prudence mentioned, the flexibility, this is what the customers want. They don't want like, okay, if I go and buy this from you, then I'm just bound to purchase all this. We can integrate all these technologies together. It's the flexibility, that's the going forward. Anybody out there that is imposing that you must buy my equipment is not future forward thinking. We have all our product offerings. We have implemented that with conviction that this features of compatibility with everybody out there. We can go and take this control system. That's the intelligence of that, to have being able to adapt to these technologies and being able to do that. Controls is at the essence of all of the aspect, and this is where we shine to the controls aspect of that, bringing the intelligence and solving complex problems.
Thanks very much, Adnan and Prudence. I've got to be honest with you, I sometimes wish some of the consumer electronics companies would take a similar approach to compatibility, but that's another story for another day and another industry or so. Okay, folks, well, yeah, we promised you a webinar. We've kind of given you a feature-length movie, I suppose, but an enjoyable one, I hope, and informative too. Just remains for me to thank very much our friends, sponsors, and clients at Honeywell. Thank you so much to you, Adnan, and to Prudence for the benefit of your expert advice. It's been a real pleasure working with you. From my perspective as well, overall, I think the biggest thanks does have to go out to the audience. Thank you so much for joining, whether you're watching live or watching later on Catch Up on Demand. Thank you so much for being part of this great, dynamic, fast-moving, fast-growing industry. Yeah, we hope to see you next time. Thank you so much for your engagement, involvement, and for all of your efforts. And we'll see you again soon. Bye-bye.